Okay, welcome back. We'll have a look at the next component. And so we're looking at trig identities. Now, trig identities exist, and I've done this quite a bit in the white sheet. And apart from all of your bits and pieces here, essentially when we've got a triangle that's got denoted this way on a unit circle triangle with y and x, and this is our associations. Okay, and this is our associations. So our associations lead us to sine theta is equal to y, and cos theta is equal to x. And that's the difference, isn't it? We've got alternative names for y and x. Okay. Importantly, if we do Pythagoras, we'll get Pythagoras using the x squared and y squared nomenclature. And that leads us to, well, if x is cos, then we can substitute cos squared. We can use the association. And it doesn't matter what the variable is, we can just put it in. So theta x, y doesn't matter. For y, we can use sine. And it doesn't matter what the variable is. The variable can be very counterintuitive, and it can be very upsetting. It doesn't matter. It can be theta, it can be x, it can be y. But the sine idea and the association is very powerful. Okay, so we want to use that association of ideas. It doesn't matter what the variable is inside the brackets. We're just saying that sine is y and x is cos, and it doesn't matter if it's the cos of x or the sine of y or the cos of theta or the sine of theta or whatever the variable is. It doesn't matter. So this is where we've got now unity triangling. The next thing I've challenged you to divide through by cos squared. In another version, divide through by sine squared, and get a whole range of supporters that you can help. And that includes rearrangement. So now we've got substitutions for these in terms of rearranging. Also useful is an understatement. All right, the sum and difference formulas, these you may not have encountered before. The proof will be left for you to go and look on the internet or check it out yourselves. But essentially what it requires is you to recognise these, to recognise them in both their forms. It's not always obvious. It's not always obvious, and it's not always straightforward. Okay? So, for example, if we think about cos well, let's think about, we've got some questions here, I think. Sine 15. Okay, let's look at sine 15. So, A, how on earth does that relate to what we're looking at up in that table? How on earth? Well, it needs you to do a little bit of thinking. Okay, so first of all, let's put the brackets in and see if we can. Okay, so we're going to make 15 up of either a sum or a difference. How come? Now, let's use exact values. Oh, that's a helpful thing to do. Okay, let's use exact values. Sine. Now, what has a difference of 15? Dun, dun, dun. 45 take away 30. Yep. So now we've found an equivalent. We found an equivalent, and we have 45 minus 30. Why is this so important? We're getting to it. So let's go up to the difference, and we see that we've got alpha, beta. You can remind yourself of those. And say sine 45 multiplied by cos 30 multiplied by cos 30 So that gets our first part out. Now, what do they mean? Ah, here you say, the white sheet. And we're doing minus. Now, cos alpha this time is cos 45. Okay, so we're substituting these in, treating them like a substitution. Very good. Finally, we get sine, and sine beta is sine 30. So there is our equivalent. Now, what has made this so interesting? Well, these are exact values. Exact values now need to be recognised. Enter the white sheet. Diminishing triangles. 45 degrees, same size. Ah, is that right, is it? Yes, it is. 45 degrees is pi on 4. Half is pi on 2. There it is, which is itself half of pi. Okay. What about these sides? What are these sides? What's their magnitude? 1 over root 2. We've learned that. So, all we need to do is the association. The proportion, large or small, same. And the sign. I'll do it that way for this one. So there's the thinking. Okay. Sine. Association. Y. This bit. Y of 45. Same length. Same. Both sides not greater or smaller. Same. So it's plus 1 over root 2. And I like to write them directly underneath. 1 over root 2. Okay. Alright, cos 30, what's that? Well, here's my 30, here's my diminishing triangles. Here's my 30. What are the sides? You should know it off by heart. I'm sorry, you just should. Okay, at this point in your careers, you should know this without thinking. Okay, 30 degrees is the smaller angle. And the smaller angle has the larger denominator. Okay, so cos is, by association, x. Larger x positive. Larger side x is positive. So it's root 3 on 2. Labouring it, aren't I? Alright, cos of 45 is the x. Oh, it's the same, 1 on root 2. That's not difficult. And the sine of 30. The sine is y, it's the smaller one, and it's positive. So we want a half. Wow. Is that all that we were required to do? So, taking this up here, we'll take root 3 on 2 root 2. Minus 1 over 2 root 2. Adding fractions, one of the 6 things. Same family, never changes, does it? It's always the same. Can you do it now? Can you do that? Okay. Now, we can rationalise the denominator. Alright, we can leave it. Some lecturers insist on rationalising the denominator. If we were going to do that, we would simply times by 1, because it wouldn't change it. Okay, it wouldn't change it at all. And so the only difference there is that we would do 2 root 2 times 1, which would be 2 root 2. 2 root 2. So I'm accepting this answer. Okay, accepting this answer. But I just wanted to show you this. Now, 2 2's are 4, and root 2 times root 2 is 4. So on the denominator, we'll have 4 times 2. Now, I'm not doing the product, because I want to show you something. This top one is root 3 minus 1 times 2 root 2. It's just as easy at this point to cancel. This now has to be an expansion, and we've got a quarter on the bottom. So we'll take a quarter out, just for the sake of it, and we'll have root 3 times root 2. So this is just the algebraic gymnastics. You've done the problem. Minus root 2. We can't do anything with that algebraically. We don't want to break any rules. This becomes root 6. It's allowed to be 3 times 2. It's allowed to progress from this per the index rules, really. That's your algebra at work again, even at this late stage. And so the final answer we can get is 1/4 times root 6 minus root 2. You have to leave those because they're not the same family. Okay? So that's your final result. That one would have been okay. I think they'll want you to put it in that form. So there's a little bit of algebraic gymnastics, but the most important thing is that we saw was that we had to use substitutions and exact values tricks. Guys, did you do your white sheet? Really? It's important you must do your white sheet. Okay, let's have a go at B. Cos 75. What can we do with cos 75? Cos 75. Is there any way we can do something with cos 75? What about 40 and 30? 45 and 30 is 75. So in actual fact, we can make this a product, a sum of 45 plus 30. So there you go. Guess where it's leading? Exact values tree. So cos plus, it's this one. You can do your alpha, beta if you need to name them. Just to remind yourself, then you look up and you make your substitutions. Cos 45. Cos 30. That's your product. Minus sine 45. Minus sine 45. Sine 30. Really? Is that how easy this is? Got your exact values tree? I hope you do. X at 45 degrees. Same. X at 30 degrees. Where did you get that from, Jason? The white sheet. Sine 45 degrees, same. Y. Sine is Y. 1 on root 2. And sine 30 is the small one. Is the Y on the 30, which is the small one, which is a half. Okay, so we'll go root 3 on 2 root 2 minus 1. Same family. So if you want to, you can write root 3 minus 1 over 2 root 2. And if you notice, that was this answer here. So this is also and I'll leave you to do the working. Okay. So 2 answers, similarly using exact values tree. I hope you did your sheet. If you didn't do your sheet, you're wondering what's going on, and you're really not recognizing what's going on. That is the reason why I've insisted so much. Okay? Insisted so much. Alright, 10, 105 degrees. Let's go up and see if we can make a sum or a difference. So what have we got? 60 45. 60 and 45 will get us there. So tan 60 plus 45 is 105. So that's our substitution, which further leads to tan alpha plus tan beta, tan 60 tan 45 as a product. Then 1 over 1 minus, that's correct, isn't it? 1 minus tan alpha, tan beta, and that is a plus sign in it. So let me do that first, tan. So I wrote the plus sign, I just didn't write the tan. That's better. As your exact value is true. It's reused a number of times, isn't it? So for our exact values tree, 45 looks like this. Tan theta is y over x, or 1 over root 2 divided by 1 over root 2. Oops. Which equals 1 over root 2 divided by 1 over root 2. How's your gymnastics going? Which is equal to 1 over root 2 times, oopsies, 1. Tan 45 is 1. Are you serious? Yep, so they're all replaced by 1. What about tan 60? Tan 60 is this one. By recognition, root 3 over 2, unit circle, 1/2. Tan of the angle is equal to root 3 over 2 divided by 100. And how's your gymnastics? Root 3 over 2 divided by 100, which is root 3 divided by 2 times, flip it, 2 over 1. Cancelling root 3 over 1, root 3. So everywhere we see a tan 60, put a root 3. Really? Is that easy? Yep. So over here, we've got root 3 plus 1, or we'll put it as root 3 plus 1, because this was a plus sign. Root 3 plus 1 divided by root 3 times 1. 1 minus root 3. Wow. Wow. So that's your final answer. Exact value is true. How are you going with it? Alright, let's go and we'll do the next one on the next video. I'll be back soon.